Well, hello, Internet, and welcome to my Wednesday machine learning live stream. Today, we're going to talk about a ton of different things. Thank you to everybody that joined me. Hello, Pop. Hello, Latjor. Thank you for joining me. And I'm very happy you caught a live stream. Great stuff. Okay, so what we're going to be covering today is a ton of different things. Last time I talked about binary convolutional neural networks, and don't worry if you've never seen one of these streams before. I'm going to cover everything in mass detail, and the great thing is if I say something that doesn't make sense, you can just ask me questions. So there's no need for doing any more. Hello. All right, so what are we going to cover today? I'm going to cover transfer learning, of course, because that's the name of the video. I'm also going to cover TensorFlow Hub, going to talk about multi-class convolutional neural networks, and what we're going to do with those is we're going to take 20,000 images of 20 different types of food, and we are going to train a model to be able to recognize any one of those 20 different types of food. So this is going to take it up to another notch. Previously, all we did was check if something was a hot dog or a pizza. All right, so this is 20 different types of food, and a lot of these foods look very similar. For example, one of the foods is apple pie. Well, very often on the plate with the apple pie is ice cream. Well, guess what? One of the other items we're looking for is ice cream. So SN7, thanks for stopping by. Also going to cover downloading and processing data, very important. And if you don't have a super powerful computer, don't worry about it. We're going to be using Google Colab, so we're going to be using all of Google's computers, and they're super, super fast. So you don't need a super fast computer to do machine learning anymore, which is super awesome. Latjor, thank you. Happy that my code helped you. We're also going to talk about activation, polling, optimizing performance, minimizing overfitting, augmenting images. This doesn't make sense. Don't worry about it. I'm going to cover it. I'm going to talk about ResNet, EfficientNet, and a whole bunch of other different things. So there you are, and thank you to everybody that is joining me here. All right, so what are we going to do first? Let's take a look at this guy. This is one of the best sites for really understanding how convolutional neural networks work. And basically what we have is we have an image. In this situation, we have a ladybug. And what it's going to do is it's going to break the ladybug into 3 different channels, red, green, and blue. For some reason, I had them highlighted. Then what it does in these convolutional layers, it is going to further break them down, and then in the activation layer, which is called Relu in this situation, it's going to try to look for consistent lines the first time through, and then later on shapes as it continues thereforth. Let me zoom in a little bit so maybe you can see this a little better. So you can see here we have a ladybug. Well, depending upon which color channel is being analyzed, different shapes are going to start appearing. And what it does, this convolutional neural network, is it tries to find consistent shapes for something that it would consider to be a ladybug. And of course, these are going to change depending upon your different types of input. So here I have pizza, and here's a pepper, and here is a bus. And as it goes through, it is going to analyze these different color channels, look for different shapes, and then say, hey, every time I see this shape, this shape, this shape, and this shape, that means this is a bus. All right? And we're just going to jump in here and sort of explain exactly what's going on. Here is Google Colab. Just type in Google Colab, and you'll be able to open it up and use all of the, I'm using a runtime CPU. This is very important. What you want to do, because we're doing, this video is going to be the first video where we do extremely intensive calculations. So to be able to do that, you need to use a GPU. So you're going to go runtime, and you're going to say change runtime environment, and make sure you have GPU selected here. Very, very important. Otherwise, it'll take a lifetime for you to make all of these different calculations, get them done. All right? So what do we got here? Well, the process that we go through in putting together, I'm going to give you an overview of absolutely everything we're going to do in the video right here. So what are we going to do? We're going to collect a whole bunch of images of like size, but they don't have to be the same size, because I'm going to show you how to take images of any size and break them down into a smaller form that we'll be able to use. But they should be somewhat the same. You don't want images that are 4,580 pixels and then other images that are 28 pixels, okay? Like, that's going to not be good. We then have to split those images into training and test sets. We're going to discover potential labels and features. Labels are the random shapes that it finds in the images, and the labels are going to be ladybug or bus or pizza. Okay, so that is the target we're aiming for. The feature or the features are the random shapes that are found whenever we look at an image of some type of food. It doesn't have to be food. This can be absolutely anything. We could do faces. We could do anything we want. Any type of object you can imagine. We're then going to flatten the image into tensors, and that just means we're going to take everything is going to be represented as a pixel. And remember, we're using color channels, so it's going to be, each pixel is going to be a certain percentage of red, green, or blue. And I don't know if you are aware, but normally whenever we are defining how much red, how much green, how much blue, that value is between 0 and 255. Well, we're going to have to go and make that into a number that we're going to be able to use, and that's called normalizing. So we're going to convert the values of 0 to 255 down into values that lie between the values of 0 and 1. Okay? I think that's understandable. Again, if I ever say something it doesn't make sense, just ask me. I am going to get into natural language processing probably not, maybe not the next video, but the video after that. Somebody just asked a question. Okay. Then what are we going to do? We're going to increase our hidden units, our layers, and what they do is they add weightings to get desired output. That sounds complicated. Not really. It's just saying whenever this pixel is lit up and it is next to these other pixels that are also lit up, and that ultimately gives us a final value for ladybug, well, it's saying those pixels are important and other pixels that don't have those shapes are less important. And there we go. Every time I say something, I'm like, I could keep talking about this, but I'm going to try to keep it brief. And if you want more information, like on weightings and things and how they work, I can get more into that, but I'm not going to bother. Remember, we're just looking for lines that then become curves, that then become shapes, and then we go and say, every time we see these shapes, this is more than likely a ladybug versus a bus. And a good way to think about this is in our last example. Well, let's think about the difference between a hamburger and a pizza. Okay, if you have a pizza, very often people put pepperoni on a pizza. So what does that mean? That means, thank you very much. I greatly appreciate that. A pizza, very often people get pepperoni on it. So what does that mean? Well, if you look at an image, that means that the image is probably going to have a bunch of circles on it. Okay, have you ever seen a situation in which you saw a whole bunch of circles on a hamburger? More than likely not. So there you go. That's sort of the way of thinking. We're looking for a whole bunch of circles if we're looking for a pizza. Another thing, like if we were looking at a pizza versus a hamburger is round. The bun is round. The whole entire object is kind of round. A pizza, however, especially if it's a slice of pizza, is going to look triangular. Okay, so those are the types of differences we are looking for whenever our computer's analyzing and trying to figure out what information is important. We're going to add different optimization functions, and what optimization functions do is just smooth our overall numbers to help us get closer to our final result. Meaning, if it looks like a pizza in the image that the computer's looking at, the computer should spit out this is a pizza. Okay? We can mess around with the learning rate. Again, I'm talking about a whole bunch of complex terms, but they're not that bad. Learning rate, all that means is how quickly we move our values to try to get to a target value. And we're sort of like moving down a curve whenever we are, well, it depends upon how many values you have, because this could be a 3-dimensional, 4-dimensional, 5-dimensional, depending upon how many different features you're analyzing. But we're moving towards a number, which is ultimately going to represent the correct value. And learning rate just means how quickly are we going to be changing those values to get to our target. Now, the positive of it having a a high learning rate is that you get to that number quicker. The negative is you might overshoot past it, and then you got to go back, and then it's sort of, you're creating this backwards and forwards sort of motion. All right. Well, thank you. Yeah, I have more people watch my videos in India than any other country, surprisingly enough. How many videos am I doing on machine learning? It all depends on you guys. If these videos get a lot of views, I will make a lot of them. This is what I do for a living. So I know a lot about data science and machine learning, so I'll make as many as you'd like. All right, if you're totally new with machine learning, you should be able to understand this as long as you have somewhat of an understanding of Python. All right. Can I change the learning rate while training? Yes, we use these things. I covered that 2 videos ago. And what you do is you use what's called a callback scheduler, and it automatically goes and changes the learning rate constantly as you're trying to make your model, create your model, which the model is like the brain that is going to make the predictions for you or do all sorts of things. So you can think of the model as like this brain that has this very specific talent. In our situation, in this video, we're making a brain that's going to be able to look at 20 different types of food and tell you exactly what they are. All right. And yeah, so like 20, I'm not going to cover that in this video, but 2 videos ago, I showed how to find the maximum learning rate. It's not terribly important because the maximum learning rate almost always is 0.001. So there you go. I just told you the maximum learning rate. And in that video, we covered that also. All right, so I covered all that stuff. So now what are we going to do? Well, we're going to make sure that we have a GPU that we're borrowing from Google. I showed previously how to get that. If you missed it, you just go to runtime and you say change runtime type and make sure this says GPU. All right. Okay. Well, I'm not going to show you the images. Let's see how powerful of a computer Google is letting us have access to 100% for free, which is pretty awesome. We're having a Tesla T4. This is almost always what we get, and you can see the size of it there. All right, and sometimes you get a faster one, sometimes you get a slower one, but you deal with what you got. All right, I'm not going to cover all the imports and stuff because I've covered that before. There's NumPy pandas. I'm using the random number functions. I'm using PyPlot. I mean, this is all math and data science libraries, either for working with data or plotting that information, and you're going to see how that goes on. After this video is done, probably an hour afterwards, I'm going to upload everything to GitHub 100% for free, and it's going to be heavily commented, so you can use it as a cheat sheet, and you could just dump the whole entire thing right into Google Colab and run it. So I'm not going to go into all of these different things and what we're doing with them. I just have them here. I'm going to run this, and I'm just going Shift and Enter, and that is going to process it. Okay, so now it comes to the data we're going to be using. I'm using a wonderful site called Kaggle, which is going to allow you to it's going to allow you to get all kinds of different data sets. So we can just click on it, and this is the one we have. I think, I have no idea. There's 101 different types of food. What I did was I broke them down into 20 different, I don't have 20 fingers, obviously. 20 different boxes, and let's see if I can find it here. So here it is. It bounced over here for some reason. This is something you're going to have to do on your own because there's just no way for me to easily, I don't believe I can take this image. It's 947 megabytes. There's no way that they're going to allow me to put that inside of there. So what do we have here? This is a zip file, and I believe I have that's the Google Drive. Okay, so here's the Google Drive, and let's get rid of that. And then there's another one. Let's try this, and it moved it over here again. All right, I just want to show you how I organized all of these different types of food because it's very important. So I have a folder called Food Images, and then I have a folder that is called Test and Train. And inside of the Test and Train, can I just do this? I never do this. Well, anyway, there is a whole bunch of different types of food. So I have apple pie, breakfast burrito, Caesar salad, cheese plate, cheesecake. I have 20 different types of food in separate folders. and then I went and just dumped 800 of those images that I got from Kaggle into the training folder, and then 200 of the images into another folder called test. All right, so just so you can see how this is organized, there's a test folder and a train folder. The train folder, just like the test folder, has an individual label. It has to be exactly the same for all of the different folders. Yes, that's actually the last video I did was inspired by the Silicon Valley episode, which was hot dog, not hot dog. That's what that was for. Use all the more images you have, it depends. I mean, there's actually another site called ImageNet, and that is very often used. They have millions and millions of different images on there. And we're going to get in as this video continues. I just wanted to show. Okay, so you're going to have a folder called food images. It's going to have a folder called test, another one called train. And inside of both of them, we're going to have folders that have all of the different names for all of the different types of food we have. And then inside of those, we're going to have images. And the only difference between test and train is the train folder is going to have 800 of those images, and the test folder is going to have 200. Okay? So that's an overview of all of those different things. All right? And then I'm going to also, on GitHub, have all of this stuff. And you want to split up the images into training and test folders. All right? 800 to 200. There you go. No. See, it keeps bugging me because I'm using its GPU, and it's like, hey, stop using my GPU. I don't like that. All right. So what we need to do is I went and put all of those images on a Google Drive. And I want to go and access them from there. You don't have to use a Google Drive. You can use any type of online storage, or you could use your personal computer if you have a very fast computer with an awesome GPU on it. Okay, so if we want to mount our Google Drive, this is exactly how we do it. We just go, drive, mount, and it's going to be content-g drive, like that, and we will run it. So I'm going to switch over here so I don't show all my personal information. So I'm going to say connect to Google Drive is what I just clicked on. I'm selecting my specific Google Drive I want to use, and I'm telling Google that, yes, it's okay for Google to use my information. All right? And as soon as it mounts, I will bounce back over and show you the code. So what exactly are we doing here? I'm taking 20,000 images, and I'm training my computer to be able to look at any one of those images and images that it was not allowed to analyze, and I'm teaching it to be able to recognize 20 different types of food from any image on the face of the earth. That's what we're doing. That's what this video is about. And I'm going to show you how to do that in multiple different ways. Some ways are going to be super awesome, and some are going to be super slow. I think AI will solve any huge problems with the future. If your GPU's terrible, who cares? Use Google's. That's what I'm using. I'm using Google's computer right now. I'm not using my own computer. I'm obviously using my computer, but this is in a browser. Just type in here. I'll type it right here. Well, here. Google, I'll put it right here in this code. Maybe I want to increase the size of this so you can see it better. Okay, so just go to Google and type in Google Colab. All right? That's what I'm using. Just open up your browser, type in Google Colab, hit enter, and go to that site. Boom. You can use all of Google's computers, and I'm promising you, they're probably, like, I have a what do I have? A NVIDIA 3090 GPU, which is like wicked fast. The Google Colab's almost as fast as that. Okay, so like this is so ridiculously awesome. The only reason I have a personal computer that is super fast that I use is because I do work stuff, and very often I use insane amounts of extremely large files. And on top of that, very often my clients don't like the idea that I would be putting their personal information anywhere. So that is the reason why I use my own computer. That is the only reason. If you don't have insane amounts of data, even if you do have insane amounts of data you want to work with, you can still use Google Colab, but at a certain point you have to pay them. But for the stuff we're doing here, you don't have to pay Google anything. And I mean, look, well, here's my disk right there. So you can see how much space I'm taking up. Okay, so it's going to be data and food images dot zip. And what I'm doing is I'm just referencing in my data folder in my Google Drive is a zip file called food images. And I'm going to get that and unzip it. And then you type in my files.extract all. And I'm covering, as you can see, I'm covering all the basics. So even if you have never used machine learning before and you have a little bit of understanding of Python, you should be able to understand all this, okay? And if not, just ask me a question. Derek, recently found your channel. What is your I run a bunch of online stores, but I do inventory analysis is one of the major things that I do all the time. Yeah, it's free. There you go. All right, so we got all of our different files, and we can come over here to our files, and you can see food images. And here's test, and here is trained. So just if you want to see, and you can see the test folder, apple pie, breakfast burrito, all of that different stuff is in the test folder, and exactly the same exact folders are in the train folder. The only difference is train's going to have 800 images, and test is going to have 200. And there are all of the images. And I think they're all JPEGs. I'm not 100% positive. But one thing to know is it doesn't matter. Like if you train on JPEGs, you don't have to always analyze JPEGs. That's a question somebody asked last time. Doesn't matter at all. Okay, so what do I want to do now? Well, one of the best things to do once you get your images is you want to analyze them. One of the funny things, I hope and pray it actually comes up whenever I analyze the files. But remember I said one of the images, or one of the things we're going to be analyzing is apple pie. One of the images in the apple pie folder from Kaggle is actually a picture of an Apple iPad, and there is no pie anywhere. So these images are not perfect. I just saw that randomly whenever I was analyzing them using this function. So I'm going to say I want to analyze a random image. So let's just call it display random image. That's good. And we're going to pass a directory and then a class type. Class type just means what type of food are we looking at. And it's just a way for me to traverse the directory that I just showed you multiple different times. All right, so what do we got here? Well, what I want to do first is I want to define the directory to look in. So I'm just going to call this image directory, something like that, is equal to directory plus and a / like that, and class type. And like I said, that's just going to allow me to traverse the directory. If you need me to show you what I mean by that, class type. There we go. So there is our directory that we want to look at. Now what I want to do is I want to get all of the files from that directory. So I'm going to say files is equal to os.list directory, and then pass it the image directory. Up then, this is going to show a random image, so I want to pick a random image from it. Yes, this is all, that's what machine learning is, largely just math. So if you get good at data science, it's just a progression into it. But you don't need to be a data science expert by any stretch of the imagination to be able to create models and analyze all this stuff exactly as I'm doing it right now. That's why TensorFlow exists. TensorFlow and Keras and PyTorch, they exist as a way to, so you don't have to necessarily think that much about the underlying mathematics. And then after you get really good with TensorFlow or PyTorch or Keras or whatever, then you can progress onwards and start learning the math. But I think it's a much better path to jump in this way because it gets you excited about the potential, and then you can sort of slowly put your toe into the whole entire process instead of, you know, just confusing yourself about all the different math. Because I'm covering a lot of different jargon here. when I talk about convolutional neural networks and activations and all that stuff, well, if you learn all that stuff using libraries like TensorFlow and PyTorch, well, then once you have to do the mathematics for it, that jargon is already 100% understandable to you, and you don't need to learn anymore. And I'm trying not to make any typos here as I talk and I code at exactly the same time. So what this is doing is just picking a random file, and what this is doing is it is going to allow us to print out onto the screen said file. So I'm going to go I am show, and I'm looking at multiple different monitors and everything. And do you guys think this is input that would greatly benefit me if you would take the time to type in the chat? Do you think this way of learning is better than what I used to do, where I would just make a video, you wouldn't see me, nobody'd be able to answer any questions? Or do you prefer the extremely lightning fast videos that I used to make? Because these, of course, since I'm answering questions and doing all this other stuff, this is slower. Because depending upon your input, I very well may stop doing live streams, or I may do something where I do live streams plus what I used to do. Hi, Brendan. Thanks for stopping by. Image, and because I try to do what you guys want me to do. That is my whole entire goal. And what this is going to do is it's going to print out information on the resolution of the image. All right. So that's a function. And now what I'm going to do for review topic, lightning fast method is good. All right. Well, I don't know. Maybe who knows what I'll do. I constantly change because I hate when my channel becomes boring. So what I'm going to do here is I'm now going to use that awesome function that we just created that basically just goes and finds a random file and does stuff with it. Lightning fast video is good for quick reviews for intermediate and advanced topics, but I found you from your probability and statistics video. This way is better, allows us to absorb the information with harder topics. Okay. Well, thank you. All right, good. All right, so what I'm doing is I'm looking in the training folder, and I'm going to say that I want an apple pie. And I'm going to cross my fingers and hope that it opens and displays an Apple iPad, because I think that would be really hilarious. And what is that? No, it's just a boring apple pie. Let's look at another image. I want the Apple iPad. There's an Apple iPad somewhere in this data set, but I can't find it, of course, because there's 2,000 images. And as you can see, the images are quite different, okay? So let's go and let's look at a couple more. But I think we can, let's see, there's a pie, but there's also an ice cream. See, whenever you're first starting analyzing images in this situation, you want to go through and look at these random images and think, okay, what could potentially be a problem? All right, well, there's ice cream on a lot of these plates, and one of the other things I'm searching for is ice cream, because there's ice cream again. So what's going to happen if we end up getting an ice cream? That looks like a pancake to me, but I don't know. Whatever. So maybe we want to look at some other different images. And this is always extremely important to do whenever you're first starting off. So let's say cheesecake. Okay, so let's see some random pictures of cheesecakes. All right. All right, super. Okay, so there's a cheesecake, and it sort of looks like a cheesecake as far as I know. I don't know. That could be an apple pie as far as I'm concerned. I don't know that much about cheesecakes. But you could see that in general, it's sort of, kind of, we're hoping and praying that this might work. And there you can see. So far, as I'm analyzing this data, I'm basically thinking to myself, well, the ice cream that is often on the plates with the pies and then the whipped cream and all that stuff might cause problems in us being able to recognize ice cream. But let's find out. I might be completely wrong. Let's see what ice cream looks like, by the way. So I have ice cream also is one thing we're analyzing. Okay, that's ice cream. All right. So, as you can see, the image data that we're analyzing doesn't need to be perfect. And just to tell you right now, this is going to be successful. I don't want you to think that what I'm doing here, I'm going to ultimately say none of this worked. That is not going to happen in this video. We are going to have success in this video. I'm just pointing some things out. And there is our Polo Club site that I talked about previously. This is what I'm talking about. This is the Polo Club thing. Okay, so we looked at our images, and now what we want to do is we want to prepare our data. And how should we do this? And then maybe I'll step through and talk about the different parts of the convolutional neural network, and then we'll get into transfer learning as you go. Do you think data structures and algorithms are something that developers need to really master to get into heavy data science? It doesn't hurt, is what I'll say. Do you have to? No. I say when you're learning, a lot of people have a lot of trouble. They say, I'm not motivated, or I'm having trouble getting motivated, and how do I get that question constantly. And what that means to me whenever I hear that is you're not having fun. So you need to figure out how to make your learning process more fun, if at all possible. And if just jumping in there and just having fun is, I mean, that's how I started learning code. And I think a lot of people miss that. Like for example, what I'm doing right now, very often, because I do a lot of machine learning stuff, I do these calculations and I hit enter and then I sit there and I wait for 10 or 15 minutes for calculations to be made. And I don't have anything to do. So what I very often do is I pick up a hobby. One of the hobbies I have right now is I'm trying to learn how to play guitar. Okay, here it is. It's always sitting at my desk. It's always ready. Anytime I have 10 or 15 minutes where I'm making a calculation, I pick up the guitar and I work with it. And I use a program that's called Musician, which is basically a game, and I play the game. And I have fun with that, and that's how I do my day. So if you're having a hard time getting motivated, what you need to do is figure out how to make your learning process more fun. Okay? Have you read Cracking the Coding? Now, I don't read that stuff because I work for myself. I don't need to try to impress people. I normally go directly with the clients I work with. I go directly to the CEO almost always, and that's the person that I deal with. I don't deal with any coding people or anything. They wouldn't invite me there if they didn't already know I could do the job. And I have a very specific data set, or I have a very specific skill set that I use to do my job. And I've been doing it long enough that I get referrals. So I don't normally have to walk in and try to figure out if they want to hire me or not. It's more than likely, it's me deciding if I want to work for them. And that's not an arrogant thing. It's just I'm old and I know what people I work with and what people I don't. Okay, so what we're doing right here is we are normalizing our data. I talked about this earlier. All of our data we're using color channels, remember? So color channels. And this is going to be a percentage of red with a value between 0 and 255. Green is exactly the same, 0 and 255, and that is a measure of the percentage of red, green, and blue in our image. And what we're going to do is we want all these values to be between the value of 0 and 1. Well, to do that, how do we do it? If our maximum number is 255, well, we divide by 255. And that is going to guarantee that all of our data is between 0 and 1. Okay, it's just basic math. So people are like, do I have to be a mathematics expert to be able to understand this? Absolutely not. It helps, but you do not need to do that. All right, so we have our training data and our validation data, and this is just defining that I want to be able to normalize that. I have to take a drink every once in a while, I lose my voice. That's funny. So here we go. So what I want to do now is I want to load my data and I want to turn it into batches. So what that means is I want to take each of the individual images, I want to convert them into 256 by 256 pixel resolution, and I want to also get 32 images at a time. Why 32 images? It's like a thing. There's somebody that was like a super genius in machine learning at one point in time that said that 32 was a magical number for processing, and so that's what I do. It's like a kind of an industry standard as well as I know it. So I'm taking all my images, I'm converting them to the same resolution, and then I'm getting 32 images at a time that I will then analyze. Call this train data. And then you go train, IDG, and flow from directory, and pass in my training directory. And it's going to create batches of these images. Oh, I love it whenever it goes exactly where I want it to go. And you'll say, well, how hard is it to convert to the same resolution? Well, it's terribly hard. You type 256 like that and 256. There you go. You just converted your image into a 256 by 256 pixel image. Batch size, I want it to work with 32 images at a time, and that's so we don't run out of memory on our computer. And class mode, what are we working with this time? Well, we're going to be working with categorical data. Previously, we were working with binary because everything was a hot dog or a pizza. We no longer live in the world of hot dogs and pizza. Now we're working with multiple different things. I have a minor technical issue here. Okay, so let's just get this here. So categorical. And then we're going to do basically the same exact thing here. I see that I got another chat. Thank you for all the input. This is why I like doing live streams, because I love interacting with everybody. It's a popular number. It is. The 32 is a good number. All right, so what are we going to do? We're going to do this with our validation data also. So our validation data is going to be exactly the same, except we're going to obviously train this from train to validation. And I'm reading all your comments as you go. Yeah, 32 is a magical number for batching images. There's a super genius, I believe he works for Facebook now. And what did I do wrong? Training data is not defined. Or training directory. Train directory. Oh, I just forgot to hit enter here. Or shift enter there, I bet you. Run it. There we are. Found 16,000 images and in 20 classes. Those are going to be our training images. And then 4,000 images belong to 20 different classes. Okay, so what am I going to do now? I'm going to prepare a multi-class CNN model, convolutional neural network. Why is it multi-class instead of binary class? Because I'm picking from 20 different types of food instead of 2. So that's the reason why it's there. Google is yelling at me. If I don't soon use this GPU, it's going to take it off of me. So I want to find out how much, the number of batches I'm going to have if I have 32 images. Well, it already told me 16,000, so I'm going to go 16,000. Just verify that this is going to work. So let's run that. 500, 500. So we're going to have 500 batches of 32 images. Good. Now we can create a model, and then Google can be quiet and be happy that I'm using its GPU that I've been borrowing. I should be nice to Google because, not because I'm making these videos on YouTube, but because I should just be nice, huh? They're giving us these computers for free, so the least I could do is be nice. Okay, so what am I going to do? I'm going to create a convolutional neural network. Where is this coming from? Right here. I'm using this. Activation, Relu, right here. Another convolutional network. Another Relu, activation. I talked about what these do earlier in the video. Max pooling. I'm going to cover, after I type in this, well, yeah, you know what? I'm going to cover it really, really fast. Okay? So basically, with each of these convolutional neural networks, we're going to have an input layer. It's going to have 3 channels that are going to represent the RGB channels, okay? We're going to have a convolutional layer. It's going to add weights that are going to extract features that differentiate the images. So it's going to try to find images or shapes that represent a specific image. You have Relu. This is called an activation function. What it does is it's used to produce nonlinear decision boundaries. What does that mean? It means linear is straight lines. It's trying to fit these shapes better. So if you want to look for like a weird shape in an image, okay? Well, there's no way you want to be able to draw around it and be like, here's the shape. You don't want to, use this. There's no way to represent a shape of very weird proportions using nothing but straight lines. So Relu is going to allow us to do that. It's going to allow you to get out of the linear straight line world and start making actual circles around specific shapes. I'm not dramatically, but I'm slightly simplifying what I'm saying here. Okay, what else am I going to do? Well, we're going to have pooling layers. What's a pooling layer do? It's going to summarize feature maps. Basically, what pooling does is it provides a summarized version of the features detected in the input. And they're used so that small changes in the location of a feature in the input will result in in a pooled feature map in the same location. So basically, pooling just, it often helps in situations in which your model overfits. And I'm going to cover overfitting later on. But basically, just briefly, overfitting means that we create a model that tries to be extremely accurate with our training data. And in doing so, whenever it sees images it's never seen before, it's wildly inaccurate. And one way of understanding that is, let's say that to prepare for a test, instead of actually learning how to solve problems, you instead go, well, you memorize every question and the right answer for every single question. So you're like, okay, well, if I ever see a question that involves Raul and Paulo going swimming, the answer to that is 34. Okay, so you memorize that. And then you do the same for something else. Well, you never actually learned anything. All you did was you memorized Paulo and whoever the other guy was swimming, okay? So you memorized those things, but you didn't learn the underlying concept of how to solve any problem like that. Well, then the teacher lays the test down, and those 30 or 40 questions and answers you memorized, none of them are on the test. And you get an F. You get them all wrong because you never understood the underlying concept of how to solve problems. That's what overfitting is. It memorizes very specific things, and in doing so, it whenever it sees similar things, it gets them wildly wrong. It doesn't understand them. Okay, so that is what pooling is. One of the things that allows us to do that. That's a way of getting rid of it. And there's some things actually missed here. So we're going to flatten our layers, and that just converts a 3D layer into a one-dimensional vector. And then you're going to have a final activation function that is also not listed here, and it's called softmax. And what it does is it's used to scale from multiple different tensors into your output probabilities. And that sounds complicated, but it isn't. If you know you're going to have 20 possible answers, well, that's what the softmax function does, is it takes mountains of data and it says, okay, we want 20 potential answers here, and convert down. Okay, I think that all made sense. And I covered this in the last video, but basically the way that we analyze is there's going to be a box that is going to go from left to right. And it is, this used to, oh, there it is. There you go. So basically, let's input size. Let's increase this. Is it working now? There you go. Okay, so let's increase it to 6. Okay, so this is basically how a convolutional neural network is going to work. It's going to bounce across, and it's going to analyze all of these pixels and go down here, and then it's going to continue doing so until it gets all of this pixel data. That's how it's going to do it, left to right and top to bottom. Padding is this part around here, and we use that's the darker part. You can see now it's gone. Well, why would we use padding? Well, if we use padding, that guarantees that we're always going to touch each pixel multiple different times. That's why we're using that. And you can see here, stride, what it's doing is it's jumping 2 spaces each time that I move this is actually called the kernel. And here we will move 1 space at a time. So there you understand padding, kernel size. Kernel size, it's just a 2x2 kernel. And that's the pink thing you see moving there. And that's called a kernel, sometimes referred to as a filter. Boy, we're covering so much stuff. Okay, let's get back to what we're doing here, which is creating a model. So what I'm going to do is I'm going to show you how to prepare a multi-class convolutional neural network that I'm going to call a CNV from now on. I just covered what they are, so hopefully that makes 100% sense. Anybody have a question? The filter, we're trying to find images, or basically, and the kernel moves across the images. You're going to see as we work through here. Okay, so what I'm doing here is I'm just basically using exactly everything that's on this Polo Club website. Okay, that's a great place to work for. So, and then I'm adding a couple extra things. Okay, so we're going to have 10 by 3. This is what we did previously. And I need to say input shape is equal to 256 by 256. Remember, we converted all our images into 256 by 256 images. Okay. So, why is it showing that? Maybe it doesn't understand what that is. Let's move this over here so that... Okay. All right, so we got our convolutional network, and then what was followed after that? Our activation function, and I told you what all that stuff meant. I'm not going to talk about it again. Don't worry. There's probably a lot of people saying, I hope he doesn't start talking about activation functions again. He already talked about that 3 times. But if you understand it, then it's all worth it, right? Okay, so 10 and 3. And these numbers are not ironclad. These are numbers that I am just using because they work pretty good. All right, so we'll go, boom. There's our activation function. And as you see, there's convolutional network. This is activation, convolutional, neural network. And then we're going to have the pooling that I'm going to do next. So let's do a pooling layer actually right now. And like I said, if you after this video is done in a couple, like an hour or so, I'll put everything on GitHub, and you'll be able to get it, and then you'll be so happy because you'll have all this awesome information. All right, so we'll go like this, and then of course everything's free. Any chance you have an algorithm to our plan in the future? Not really. Sorry, I don't. My videos in the future, what I have planned right now, I have a data structures and algorithms video already for Java. It's done, so it's on there. All right, so how many max pools do I want to do here? Well, let's go. You know what? I'm going to do it like this, and then this is going to run, and it's going to take a while to execute. And that's awesome because while that's happening, I can go get myself some warm tea, which tastes much better than cold tea. Okay. Yes, the more you hear me say the same things, the more you'll get it. And you'll be able to just type all this code and not even think, which is the ultimate goal. If you are just here for a party, you want to watch a 5-minute video about... filled with animations that doesn't teach you anything, you're in the wrong place. If you are here to actually learn something and really use your brain, you are in the right place. Okay, so there's this is going to be our 20 possible outputs because there's 20 possible foods that are going to be coming out of here. And I want to run this model, create this model as quickly as possible so Google doesn't shut off my GPU. Okay, so after you create the model, which is just using all those same sort of things that we just saw before, you need to compile it. I called this model 1, right? I feel like I'm racing against the clock here. So model 1, and you want to compile it. So I'm going to say compile, and we're going to use loss. Loss is how far you are off from the target you are trying to reach. Cross entropy. And this is categorical. Again, there's 20 different options. That's why it's categorical. If it was only 2, it would be binary entropy. Binary cross entropy. Optimizer is going to be equal to TF. And Kara's optimizers. This is where you define your learning rate. And there's a whole bunch of different optimizers. So far, we have used Atom, I think exclusively, and Atom's pretty awesome. So use Atom. Later on, I'll cover some other different ones. I want metrics on accuracy of our model we create, and there I compiled the whole thing. Now I want to get all of the data on how well our model did. So I'm going to say model 1. Fit, and then after this I'm going to go pass in my training data, and this is going to be 20 different classes, remember, and I think I can move that up. And epochs, this is the number of times we're going to try to process and work with all this stuff. I'm going to define the steps per epoch, and that's just going to be, I want to make sure I take enough steps for all of the different batches that I have. Remember, there's 500 batches, so I just need to say steps per epoch, and this is going to have to be the same. It's going to have to be the number of batches we're working with. Whoops, I don't even know where that went. I was typing in the wrong place. Okay, and there. All right, steps per epoch is going to be equal to length and training data. And then we're going to have validation data is going to be equal to val data. The training data is going to be used to train the model. The validation data is going to be used to test the model to see if it is accurate with information that it has never seen before. And this is validation data as well. I think I got all of that right. Let's hope and pray and run it. Nope, there's an error. Okay, so what's it say? Oh, I just typed. This is convolutional. Okay, so whoops. Did it go in the right place? I hope so. I think that V went somewhere random. Let's throw that there. Let's throw this here. And input shape is going to be equal to, and input shape is going to be equal to, sorry about the typos, but that's what happens when I talk too much while I try to do this. And it looks like it's going to be fitting the model, and it is! All right, this is going to take about 2 minutes, at least. I'm going to go get tea while this... Okay. Oh, it's still not done. All right, I'm back. 4 epochs already. You can see it takes a while, doesn't it? So yeah, this is why you need a powerful computer. Um, Anybody still watching? There's still 48 people out there. That's cool. All right, awesome. Oh, it just dropped down to 46. I promise this isn't the whole video. It's just me waiting for this to calculate. It's almost done. You can see here our accuracy. The first loss in accuracy is based off the training data, and the other, that's this. I'm afraid to touch anything. And then this is based off of the testing data. And you can say, and you can think to yourself, well, 15, that's terrible. 15% accuracy on this model that's taken 10 years to calculate. Well, it's actually, you're using 20 different classifications. So based off of that, if it was just purely guessing 50-50, that number would be 5. So it's 5 times more accurate than guessing. And believe me, we're going to get up to the point where it is 86, 88% accurate. It's just going to take a while. All right, while we're doing this, Emilio just asked, what have we been doing? Well, what I'm doing is I'm creating a model, a computer brain. I'm creating a computer that's going to be able to look at any image, and it's going to be able to say, as long as it's a food image from what we're analyzing, and be able to say that it is one of 20 different possible foods. So that is what we're creating here. And what you do is you do all of this stuff. Basically, while we're waiting for that to calculate, we go and we take an image. That image is broken into red, green, and blue. And then using that, we go and we analyze to see what constant shapes are found in images that are buses. And then we say, hey, this is a bus. Long story short, that's what we're doing. We're looking for shapes. And then whenever our computer sees those shapes represented as pixel values, it is going to be able to recognize if it's one of 20 different images. And the model is still calculating, even though it's done here. And it's finally done. So our final accuracy is 0.1462. Remember, that's 3x just purely guessing. But by the end, we will make stuff considerably better. What we want to do now is we're going to take our model, and we are going to call the evaluate function on it to get our final accuracy here, and we're going to do it on our validation data. Our validation data is being used because we want to actually look at images our model has never seen and see how accurate it is for those images. If it's accurate for the training images and nothing else, so it's only accurate for images it's already seen, it's kind of worthless because we want it to work for everything. And you can see it comes down to 14.6. And let's say that we also want to come in and we want to plot this. This is pandas and data frame. This is a data science library if you've never heard of pandas. I'm trying to make this so that anybody, even if you've never heard of this stuff, can be able to at least kind of understand what's going on. And then this is a live stream, so what that does for us is if you don't understand what I'm doing, you can ask me a question. 20 and 10. This is just the width and the height of the plot that I'm going to plot, and I'm plotting the loss as well as the accuracy. So what we're looking at here is our loss, like how far off our values are, and our accuracy. Let's just focus on accuracy. So we have our accuracy, which is orange. You can see our accuracy for our training data is increasing, but for our validation accuracy, it is terrible. It actually looks like it is decreasing. That is bad. How do we fix that? That is what I'm going to cover next. It is called augmentation. So what augmentation is going, like, whenever you want to improve the performance of your model, what you want to do is add more data to it, and it gets more and more accurate. But let's say you only have 2,000 or 1,000 images to work with. You don't have no access to any more. Well, no problem. We use something called augmentation. What augmentation does is it takes all the images you already have and it rotates some of them, it crops some of them, it shears some of them, it zooms in on some of them, it flips some of them. And then magically, now you have more data. So what we want to do is do that. So I'm going to call this data augmentation. And I'm just going to do a little bit of augmenting on, you can do all those things that I just said. You can shear, you can zoom, you can do all that. I'm just going to randomly flip horizontal and vertical, and I'm going to add random rotation. So here we're going to say sequential, and brain's a little bit out there. Let's go here. Let's go back a little bit. All right, and then I'm going to say layers, and I want to add a random flip, and that is going to be horizontal and vertical. So it's going to have a horizontal and vertical flip, and then I'm also going to do some random rotations, and let's just do 0.2 because that's what I do a lot of times. So we got that defined. Make sure you hit Shift and Enter. And then what I'm going to do is I'm going to take my model again and run it with data augmentation. So this is all using all of the stuff that we already talked about in the last video, and we're trying to apply it here, but in a better way with a much more complex model. And you're going to see dramatic improvements here. So what we need to do is, this is going to be sequential again. Is this type sensitive like Python with force? But yes, this is Python. Yes, there's other ways, other languages you can use. R is a language you can use for machine learning, and Python, and you can use C, but it's not C++, but it's not. I use Python. That's what I use. So now what you're going to do is you want to put your data augmentation, your flipping, and your stuff like that directly inside of here. And I don't believe I need to change anything else. Everything else looks pretty awesome. Yeah, everything else is good. So the only thing I did was I added some changes to those images, and now it's going to calculate again. So you have to wait for it. I'm not going to run away. You can ask me questions if you'd like while I sit here and wait for this to execute. No, the image size is going to stay 256 by 256, even if I rotate it. It's going to just sort of rotate it inside of that box. Any other questions? Yeah, I only use Python for data science. That's all I have ever used for it. I use Python for most things that I do. The only thing I don't use Python for is mobile applications, because I've never found anything that works very well for mobile that's Python. I've tested everything. I use C# for mobile applications, and I use C# a lot for nice looking GUI interface applications. And obviously I use JavaScript. I use Django mainly server side because Django is ridiculously secure. And so if I have like an online store and I want it to be secure, I use Django, and Django is also Python. I'm not saying that everybody should use Django, but for me, it has worked the best, because if you run online stores, the #1 priority in your life is security. Do I still use Java? Not very much, only on consulting work. I used to use Java a lot. Not so much. Java used to, at one point in time, used to be my main language, but over time, I have just changed. Can you use Jupyter to code this? Yes, you can do this on your own computer with Jupyter, and I use Visual Studio Code to do this on my own personal computer, which also works with Jupyter. So yes, all that works. How does augmentation help? Well, it takes, if you have a limited number of images, then you're going to be able to rotate them in multiple different ways, and it is going to rotate them and flip them and shear them and da-da-da-da-da, and magically you get more images, okay? Because all the model is doing is looking for patterns and shapes. So it's just like our brain works. That's the way the model works. We're just training the computer to think like us. Subconsciously, we also see shapes when we look at things and go, that's a dog, that's a cat, that's a pizza, that's a hot dog. All right. Well, we're just training a computer to do the same thing, except the computer looks at the images as pixels, and it also looks at each of those individual pixels as different percentages of red, green, and blue, or a specific color. Okay. Oh, thank God you told me that. Yes, you're correct. All right, I just sat here and did that. Well, that's a bug. That's called a bug in my brain. Well, we stopped that. Now you know how to also stop a model from running. Sorry about that. Yeah, so that's the problem. All right, so we're starting over again. So Model 2, Model 2. Yeah, make sure your Model 2, everything matches up here. That's important. Any other questions? Now I got more time to answer questions. Well, thank you, Ahmed. I greatly appreciate that. Yeah, it's just looking at the images at different angles and different rotations and different everything. Yes, it'll create different images that are similar to the ones that we already have. It's like a magical way to create more data for our model to analyze. Trying to think of if there's anything else that I can really talk about there. Yeah, so in the near future, I'm going to do more data science, machine learning videos like this. And if you're wondering about where this is going, eventually, yes, people ask all the time because I made a series on technical analysis and stock market and investing and all that stuff. Yes, I will start applying machine learning concepts to analyzing securities and portfolios and all that stuff. Time series analysis, which I actually already did a video on time series analysis and made predictions like that. It's based off of regressions, and so that's what we're really doing here is kind of regressions. That's what it is. Just a bachelor's. I don't have a master's degree in anything. I've probably taught more courses than most anybody. I mean, on different topics. That's what I spend. That's what I do on YouTube. That's what's different about me, I guess, is I make videos on, like, pretty much everything. The only thing I've ever really kind of failed at learning, and I'm not smart, like, IQ-wise, I'm average at best. There's nothing special about me. Like, people think I'm, like, super smart and I have a super high IQ. I do not. I promise you that. I just love learning stuff. And, yeah, so I make videos on everything. Like I said, I'm going to make a video. I did a 30-day guitar challenge because people ask me all the time. They're like, well, how much can I, like, I'll say, well, if you want to get really good at something, study it for 2 hours every day for a month. And they're like, well, really, how good would I get if I did that? Well, my next, in a couple weeks, a video I'm going to upload is how good can I get at guitar? I've never played guitar. How good can I get at guitar if I play 2 hours every day for a month? And I'm going to make a video and I'm going to upload it. Yeah, I love learning everything. That's things smart people say. What's that? What's something that smart people say? I'm not smart. I promise you I'm not. You want to know something I'm really bad at? I'm really bad at really complicated, like riddles. For some reason, which you would think since I'm a programmer I'd be really good at them, but there's like weird riddles. I'm not very good at that stuff. All right, so we're getting there. We're at epoch 3 of 5, and then the next part is all going to be transfer learning is what we're going to do, and we're going to go and harness the power of models that have already been created and make super awesome models. I don't have a high IQ, I promise. I know my aunt had a really high idea. She was in high IQ. She was in Mensa, but she's not even related to me. That's on my wife's side. Yeah, I was never good at riddles. I don't know why. I never tried to be, though. I just wasn't interested. Yes, I love all science and physics and everything. I'm not really into theoretical physics, though. I just never really was that particularly interested in it. Thermodynamics was probably about the physics that I started to kind of lose interest in physics. Everything up to that point, I was really into. Basically anything, especially when I was really young, because I got into programming because I wanted when I was really, really young, they had things called Ataris, which some of you guys probably don't even know what an Atari is, but it's a video game system. And a whole bunch of people were getting them, and I really wanted one, but we were like real poor, so we couldn't get one. So what was awesome is a neighbor of ours was throwing away a computer. It was a TRS-80 is what it was. And I was like, can I have that? And they're like, yeah, it's a piece of junk. If you want it, you can have it. So I took it, and I got it for free. And I was like, I can make video games with this thing. And I don't have a machine learning in 1 hour video. Maybe at some point I'll try to make one, but I'll probably try to do that eventually, but not until I've already finished everything. And anyway, so I went, and this was so cool. The TRS-80, if instead of using like people talk about floppy disks and things like that for storage, the TRS-80 saved everything on a cassette tape. I don't even have a cassette tape in my house. I was going to think I could show you one, but I think people might know what a cassette tape is. Yeah, it was like Atari with, well, no, it had joysticks. I don't remember what it was. But anyway, yeah, so that's what got me into it. What are the topics up to thermodynamics? I don't know. Mechanics and things like that. That's what I was interested in regards to physics. I wasn't really interested in anything really past that because it just didn't apply to my life and what I was interested in. But I loved the, learning about everything basically. So that's what got me into programming. When I was 10 years old, I was programming on a TRS-80 trying to make video games. And yeah, I made Pong and I made Space Invaders. I'm trying to think of every single game I made. I made so many different games. I made Pac-Man. Tetris didn't exist back in those days. Defender. I basically, every Atari game that I saw, I would look at it and analyze it and then go back home and then I would recreate it on my TRS-80 and play it. And that's how I learned to program, was just doing that. Yes, tape recorder. Yep, everything was saved on a tape recorder. And if one of those went bad, it was like losing a child. It was like the worst thing ever. If I lost a cassette, yeah, and I would print out all the code just in case I had lost it and make multiple different versions of it. But we couldn't even afford multiple different cassettes to save on. We're almost done. War games, yeah, that was I was into that movie whenever it came out. What's his name? I forget his name. All right, we're almost done doing our calculations. Sorry this is taking so long, but this is what happens. And this is why, while this is happening, like for work, and normally I'm doing way more complicated things, so I'll hit enter and I'll be like, okay, I got 15 minutes, and then I'll play guitar or I'll do something else. What about music? Yesterday I listened to this great jazz album. It's called Scenery by Relu, but I listen to rap for the most part. What music do I listen to? It depends on the mood. I'll listen to... I have different playlists depending upon what I'm doing. So I like to run, and if I'm running, I listen to ridiculously fast music. And if I am... I mainly listen to audiobooks, though, whenever I'm... I mainly listen to audiobooks, though, whenever I run. And then other than that, I'll listen to anything. I'll listen to old country. I hate new country music. I'm not really into most modern music, though. It's kind of boring to me. Yeah, rap music, things like that. Yeah, Matthew Broderick, that's who starred in it. I was going to read you the different things. I've been on a kick where I'm listening to all of the classic books of all time, and some of them are really good, and some of them are terrible. There we are. We finally finished. Okay, so what do I want to do now? Let's see how accurate this was. Okay, so we're up to 0.22%, and so that's 4 times just randomly guessing. So we increased our accuracy pretty substantially. We're going to increase it even further though. So what I want to do now is I want to get my class names, which are just the types of food that I have. So I'm going to go operating system, list, directory, food, images. I'm going to use my training folder. So there is that, and this is OS, not number, or not the number O. Okay, and let's call this class names instead of that. And class names dot sort. And you have to do that. If you don't sort them in order, when your models are going to give you really terrible results, and you're going to think, oh, this is terrible. Well, that's because the directories are sorted in alphabetical order with your models, and they're not going to be sorted up necessarily alphabetically here. So you have to do that. So that's a big thing. So if you go and you type this in or something and run it, and you get really bad results, and you're like, whoa, this is way off, well, the chances are is you forgot to sort the directory. Okay, so let's start trying to actually make predictions using this model and see if it's accurate or not. Because remember, it's like 0.22% accuracy, but that works itself out to being about 4 times random guessing. So what I want to do is I want to... Well, thank you, Omar. I greatly appreciate that. Let's do a apple pie. Did I? Yeah. And I'm going to go and analyze a apple pie picture that I uploaded to my Google Drive. And you don't need to use Google Drive with Google Colab. It's just what I'm using. And G Drive. And I have this. Well, this is my drive. Is called my drive. I never changed it. And data. And I believe I called the file apple pie. And I'm just going to go with that. All right. All right. So this is going to read in that image. And then I'm going to just go and display it so that we make sure we see it. And actually, it is an apple pie. And I don't want to show the axes and all that stuff. I just want a picture of it. So I'm going to say plot axes and mark that as false. Let's make sure I can load it. Okay, so this is the sample image that our model has never seen that represents apple pie. So what I want to do here, let's go and also, let's say we want apple pie shape. I'm going to go and throw this in here. So I'm going to go code, and I'm going to go apple pie shape and run it. And it's 256 by 3, so that's good. And, well, I'm going to need to normalize this data that we have here and resize it. So I'm going to do that down here because that makes more sense. So I'm going to create a function so that I can use this multiple different times and don't need to, you know, type out all this code because that would be kind of idiotic. So I'm going to go image, location. I'm just going to keep this very, very simple. And, let's see. I'm going to go my image and is equal to tf.io.read file. And it's going to be the image location. And I want to turn my file into a tensor. Remember, we have to turn everything into numbers. So this is going to be tf.image.decode image and my image again. That works. And what else are we going to do here? Well, I want to resize my image. And so we're just going to keep calling this my image just to keep it nice and simple. So I'm going to go my image is equal to tf.image. And we can call resize my image, and size is equal to, and this is going to be 256 by 256. And then I want to also normalize all my data. That just means to convert the 0 to 255 for the different color channel values down to values between 0 and 1. And that's just going to be my image is equal to my image divided by 255. Remember, the maximum number is 255. And then it's going to return my image. All right. So there we are. I think I typed all that in there correctly. And now what we'll be able to do is go and get this and play around with it. So I'm going to say apple pie is equal to normalize. And I have code completion turned off because it causes all sorts of problems. So where do I have this stored? There's my apple pie right here. And let's grab it and let's see if our model is any good at making predictions yet. Like I said before, by the end, we will have ridiculously powerful models that are able to make, whoops, that was dumb, hit the wrong button, that are able to be extremely accurate. It's just, I'm taking you step by step through this process so that you'll get a very good understanding of what it feels like to solve problems. Okay, so let's see, is our data normalized? Yes, it is. See, there's no values over the value of 1. This is just a background. Yeah, this is, I'm in my basement. Believe me, I've read way more books than that. And, but somebody at one point said that I should, people with a lot of books behind their head in live streams are intelligent or something. And so I made that, I like that. So I just threw it in there and was like, whatever. And I have all kinds of random stuff going on behind me. There's a drum set behind me. There's all kinds of other stuff that you don't need to look at. So I just got rid of all that. Okay, so I'm going to come in here and I'm going to make a prediction on this image that has never been seen before. And let's see if it thinks it's an apple pie or not. So I'm taking my apple pie image that I just import inside of here. You have to make the axes equal to 0 on this. And then call prediction like that. And this is going to give us what this is this is a tensor that represents the percentage chance of what it thinks the image is. Okay, so that's what this is. So what I do then is I want to find the maximum value inside of here, and that is going to tell me what my model thinks the image is. Yes, this is a real life problem that we're working through here. And I'm doing it in a way that is not perfect because I want you to understand when certain techniques are good and when other techniques work better. So what we're going to do is I want to get the maximum value inside of this NumPy array, and that will tell us then what it thinks it is. And it thinks it's a club sandwich, which is kind of weird. Let's, I mean, it's wrong. Don't worry about it. I'll correct it. So I got all this correct. I just want to verify that all of that is sorted properly. So I got that set. And I want to come down here. And, okay. So what it does is it thinks, let's try it again. I just wanted to make sure. Okay. So it looked at this, and our model that we created thinks this is a club sandwich. All right. Don't worry about it. That's cool. We'll figure it out. So maybe we want to also come in here and we want to test this for other different types of images. So for example, maybe we want to test it for pizza. So what am I going to do that? Well, I'm going to come up inside of here and I'm going to grab this guy right here, copy it, and I can paste this right here. We can, of course, create a function that does all this stuff. And what did I call this? I called it my pizza. I'm looking at my drive. So my pizza, and this is a JPEG. So JPEG, and let's call this pizza instead of my pizza. And I don't need to do this. I'm just going to get rid of that. And the next thing I did was I'm going to make a prediction on this and see if my model can recognize pizzas or not. That would be really cool. So let's go and throw pizza inside of here. and the prediction. And then on top of that, I'm going to get my class names and see if it can find a pizza. And let's, fingers crossed, see if it works. Hey, it got it. So it can recognize pizzas. So that's good. All right, cool. So our model is at least good enough to recognize pizzas. So can it recognize chicken wings? Let's call this wings. And what did I call this? Chicken wings. So this is chicken wings. And that's on this. Chicken wings is, again, this is a file that my model has never seen before. And it's trying to make a prediction on it. Chicken wings are very weird looking. So it's probably not going to be accurate. And let's run it. What does it think the chicken wings are? Oh, it got the chicken wings. I'm really surprised about that because it was like a zoomed in version of the chicken wings. And I never thought, here, you want to see what the chicken wings look like? Okay, so the only thing it didn't get right was apple pie. So that's weird. Oh, whatever. It looks like chicken wings. You get it. Okay, so I don't want to waste time with that. So, all right, our model's pretty accurate in 3 situations. It's not, but it's not terrible is what I want to say. So what we want to do is we want to use something called transfer learning to dramatically get better results. What's my go-to pizza? I just eat regular pizza. I love pizza. Pizza is my favorite food. I make my own pizza. And I have a pizza recipe on my YouTube channel if you want to see my pizza recipe. I put bread flour in it and cake flour. That's the secret. Okay, so what's transfer learning? It took us a while to get here. It took us an hour and a half to get to transfer learning. Anyway, transfer learning is going to occur when you take a model that has already been trained to perform a certain task and you reuse it to perform another task. And often enormous resources are going to be required to train a model to do really sophisticated tasks. So if you can find a model that was trained on a related task, then you can often use it and it'll cut down on your development time. Now we're going to use something called TensorFlow Hub to get access to a whole bunch of different models. So TensorFlow Hub, and we're going to import this as hub like that. And let's run it. I think it should work. Good, it does. Okay, so here's TensorFlow Hub. And it's going to provide like tons of different trained machine learning models. So let's just click on it and see what it looks like. Boom. Hey, here it is. All right, so we're in TensorFlow Hub, and it's going to give us lists of URLs for different types of things. All right, so where do we want to go here? Did this before. C models, I think that's it. There it is. Okay, so C models. All right, so what type of model are we going to be working with? Well, I have tons and tons and tons of videos, so if you want to do that, that's cool. Get rid of that. Okay, so basically, what are we working with? We're working with images. So you're going to come over here and you're going to click on image. All right, then you have to decide, well, what are we specifically doing? Let's try zooming in on this a little bit, okay? Well, we are using image classification. We're not using augmentation. That's what we did previously. We're not interested in that. So we want image classification. These are pre-built models that we're going to use. We don't need that. We're going to use image classification instead of image classifier. Feature vector. Remember, we're looking for different features. So we're going to leave that in there. Image generator, we don't want. Object detection, we're not going to use. We're not going to use any of these other things. So what I'm doing is I'm narrowing down the model. Super resolution is something completely different. We're using TensorFlow 2. And then what we have to do is to decide what type of architecture we want to look for. Now, EfficientNet is very good, and very often the higher the model number, the more accurate the model is going to be. So let's say I just want EfficientNet B7, so I'm going to select it. Remember, this is the process. We're just looking for different ways of solving our problem and giving us extremely highly accurate results. What else do I want to do? I want to do ResNet. Which ResNet would I like? Let's try V250, okay? So based off of that, we have these models. that we can work with. So let's zoom out of here. And what this is going to allow us to do is just basically reference a URL and then jump in and start working with it. So I'm going to work with ResNet. I'm going to try this one first, our feature vector, and then I'm going to try EfficientNet after that. So I'm going to grab this right here, and then I'm going to come down here where it says copy URL, and I'm going to copy it. Okay? We'll jump back over into Google Colab and paste this and go inside of here. And that's the whole process of getting some models. So we're going to build a ResNet feature model. So I'm going to call this ResNet URL is equal to, boom. Is this a beginner video? Yeah, sort of. It's kind of a beginner video. Okay, so I pasted that in there. And this is a multi-part machine learning video series that I'm doing. I'm just doing it as a live stream. Okay, so there is the ResNet model that's already pre-built. It's super awesome. And what we want to do is download it and use it for ourselves. So I'm going to go ResNet, and we just go hub.keras layer and ResNet URL. And this is going to download the model and save it as a Keras layer. And for trainable, I'm going to mark this as false. What does that mean? That means this model is going to be downloaded and it's not going to be trained on my specific images. It is only going to, it's going to work as is. So input, shape, and I want my input shape to be 256 by 256 by 3. And there's tons of different models out there, and that's something for you to do on your own. You can say, well, I wonder if there is a better model on that's available to me that I can use to get better results than Derek did. That's your goal. You always want to beat me. All right, so I'm going to call this ResNet model because that seems like a good name. TF dot, no, this is lowercase. Keras sequential. There we are, and boom. And let's move this over here. And this is just going to create the model for us. That's all it's doing. So I'm going to go ResNet layer. And this is just going to put the images through the downloaded model first. And then I'm going to take the results and say that I need 20 of them. That's what this is saying. And I'm just going to call this activation is equal to, I don't know if anybody out there can tell me, what is the activation function we use to convert down to our final list of potential answers? I don't want to interrupt you all the time. What video should I watch first? Probably the very first machine learning video. I have it. It's TensorFlow Tutorial 2022. It's 100% up to date because I just made it. So, and good luck finding up-to-date TensorFlow videos. There's some people out there doing really cool things. I forget. There's a guy who's French, I believe, on YouTube. He makes wonderful videos on machine learning. And there we go. And got it. And let's go and get a summary of how many different parameters we're using here. So summary, you're going to see it's a lot less. We have, what, 23 million parameters. Well, that's a lot. That is a lot. So what we need to do now is compile our model, and I'm going to call this ResNet model dot, whoops, compile. Again, we're going to use loss is going, whoops, I didn't mean to put those quotes there. Loss is going to be equal to categorical cross entropy. I'm used to having code completion, so that's a little weird, but it messes up the live stream, so I got rid of it. The optimizer is going to be tf.keras, and I'm going to use Atom again because so far that's all we have used, and Atom works wonderful. So let's just use Atom. And if you watched previous videos, you saw where I was able to change learning rates and things like that. And accuracy is the metrics that I'm interested in, and then we get to build it, and that also means I get to get more T. So I'm gonna go history like this, is going to be equal to ResNet model.fit and pass our training data. And epochs is going to be equal to, let's just make it 5. And steps, remember everything's in batches, so we want to step through our data in batches of 500. Is that what it was? I think that's what it was. So length of training data, and then we do our validation data is equal to validation data. So we're working with exactly the same exact stuff. Steps per epoch. I believe that's correct. And then we build our model. And then we're going to find out if ResNet can outperform what we did before. And I can let you in on a little secret. Yes, it can. And I'm going to go get some more tea. I will be back as soon as this is done calculating. All right, I'm back. Okay. So, why tea over coffee? I cannot, I have a medical condition. If I drink coffee, about a half hour later, I fall asleep. I cannot drink coffee. I used to drink coffee like a lunatic, but I can't do it anymore. It puts me right to sleep. It's like alcohol for me. Alcohol also puts me to sleep. But coffee will put me to sleep. And I'm super hyper, so I'm not French. I am not. So we're still waiting for this. It's almost done. Any other questions you have about it? You can ask me anything. I will answer any question you have while we sit here and wait. Now the secret's out. How do I have time to go and learn all these other things? Well, this is what I do all the time. I give great big, way more complicated calculations than this to my computer, and then I sit and wait for it to give me an answer. So that's what we got. And there is 50, how many people watching me? 53 people watching me. Cool. And I decided to stream on Twitch and YouTube at the same time because some people told me that the Twitch stream looks better. So I was like, okay, well, I'll put it on Twitch. And if the stream on YouTube, if somebody complains that the stream on YouTube looks bad, I'll say, well, go over to Switch or Twitch, whatever it's called. And maybe it looks better. Oh, somebody's calling me. I'm going to cancel this. All right. Well, I'm going to get that. That's actually kind of an important call. I'll be right back. Believe me, this is going to calculate. Be right back. All right, I'm back. And sorry about that. My daughter's sick, and I had to take that telephone call. Okay, so can ResNet recognize pizza? Let's find out. So I'm going to go and save some time. I'm going to go try with pizza image. Let's grab this guy, and then we just need to change this to ResNet. So let's get this and paste this inside of here like that. And pizza. So we normalize and resize it just like we did before. We're using exactly the same image. All of this is exactly the same. This is going to be different. We're calling our ResNet model. And we're going to do EfficientNet after this. And let's see. Can it recognize pizza? Can it do at least as good as what my model did? Yes, it did. Okay. Can it recognize chicken wings? All right. My model that I created before was able to recognize chicken wings. Can this? So, whoops, this is chicken. I'm just going to call it chicken. Chicken. Yes. And what did I call that file? That file was called chicken wings, I believe. And I believe it's a ping file. Let's type this in and find out. Chicken wings and ping file. Not a JPEG file. I think that's what it was. I'm just going to go with it. All right, ResNet model, this is all the same, and I'll call this chicken. And let's make a prediction. Chicken wings. All right, so it's good. Now it has the opportunity to beat my model. Can it recognize an apple pie? My model thought it was a, what did I think it was? A club sandwich. Okay, let's go here. And I believe this is called apple pie, right? I think so. Apple pie. Can it outperform me? Or my model, my original model. Apple pie. So ResNet beat me. And ResNet is extremely accurate. So as you can see, or maybe you didn't see, when we were testing it out up here, its accuracy is at 0.7812, which is very, very accurate. Because remember, mere guessing would just be 5, because if you take 100, divide it by 20, you get 5. Okay? What did you do if you wanted to train the neural network for fixed-sized images? Like for... what do you mean? The neural network just sort of warps the image into a consistent shape. There shouldn't be anything... it should work with anything. And you can see the code automatically is going to convert it down into shape. So everything should look good. We're going to get into other different ways of analyzing images as this tutorial continues. Like, for example, I'll show it one image, or I'll show it a video, and I'm going to use something called SDD to be able to search and find multiple different images all at exactly the same time. Okay, so hopefully that sort of answers your question. All right, so I want to build an EfficientNet feature model, and I'll see if it is more accurate than what we did previously. So I'm just going to copy all of this because a lot of it is exactly the same. So let's just copy that, come down inside of here. So this is EfficientNet like this. Whoops, paste it inside of there. And we'll call this, just to keep it simple, EFF. We're going to go over to the TensorFlow Hub, and we're going to copy the URL for EfficientNet. So where is EfficientNet? EfficientNet and feature vector like this. Click on that, copy URL, jump over here, paste this inside of here, paste, and feature vector 1. That looks good. And we will change this to EFF URL, trainable again, false. Our image size is 256. And softmax is exactly the same, because softmax is just going to convert it into 20 potential outputs. And let's just go up here and get the rest of it. So we need to compile this, and compile, and where is it? Paste it inside of here, and we will, whoops, yep, make sure this is EFF model. Yeah, let's change this to EFF layer. Don't want to go fast and mess something up that ends up causing me to lose time. EFF URL, this is false, this is good. EF model, Keras sequential, this is EFF layer. EFF layer, and that's good, that's good. And then we're going to go and change this to EFF model, categorical cross entropy. Remember, instead of binary, one or another, hot dog or not a hot dog, or hot dog or pizza, this is categorical. That means there's more than one. You're going to use categorical when you're using more, or more than two, I guess I should say. And I could have, in the last video, made that hot dog, exactly hot dog, not hot dog, but I decided not to do it. Train for all different sized. Yes, this works for any sized images within reason. Like, you're not going to want to have some images that are 4,000 by, 10,000 pixels and other ones that are 32 by 32. That won't work. But if they are somewhat similar in size, yes, you can use multiple different images of multiple different sizes, and everything will work out pretty good. All of that is exactly the same. And then I just need to build the model. So let's come up here and yeah, let's grab this, copy, and we'll call this EFS history like this, paste, EFF history and EFF model. And this all is the same. I don't think I need to change absolutely any of this. And let's see if the EfficientNet is better. Did I run? Hopefully I did. Nope, I didn't. Okay, so let's go here, run that. And that'll take a second or so. And what it's doing is downloading the model. And in the last video, I showed you how to save models and things. So these videos all build upon each other, and it's a lot of information. My goal is by the end that you should be able to get the TensorFlow certification. If you watch all these videos and you work with it and you study all this stuff, create your own models and such, you should be able to get a TensorFlow certification just by watching these 100% free videos. And so that's the goal. And it's working itself. It'll get there. It's downloading a massive model right now. It's not that big. Okay. There we are. Got it. And we just need to compile this. EFS history. EFF model fit. I believe all of that is fine. Don't know why there's an underline there. Do I have all of the closing brackets? Looks like it to me. Okay. And it's running. All right, this is the last one we're going to do for the day. This is the EfficientNet, and we're going to see if EfficientNet is better than ResNet or our personal model that we created. And ResNet had an accuracy of 78. So it's 78% accurate. So let's see if EfficientNet is better yet. And then what we'll do for the final part is see if it can recognize my custom pizza, my custom wings, and my custom apple pie. ResNet already succeeded. And of course you'd want to do more than just 3 tests. But there you go. And yeah, so I think if you go through all this stuff, you'll be able to do just about anything machine learning wise. That is the goal. And eventually what I want to do is I'm working on it right now. I'm trying to make a engine that can play chess. And I'm trying to also make a robot with something else called TensorFlow Lite, which allows you to use trained TensorFlow models with Internet of Things devices. And I'm trying to make like a robot that will shoot basketballs into a little hoop and with accuracy. Like accurately do that. I don't know. It depends on how many views these videos get, whether I start going that deep in. Because it's kind of, silly for me to make videos like that nobody watches because it's time consuming. It takes insane amounts of time to do stuff like that. But we will see. And while this is working, you can ask me any questions that you might have about anything else. Yeah, it doesn't matter what the image sizes are that you're working with because we converted down to 256 by 250. Is that 256 to 256 is what we're working with. And where is the part where I went and converted all of my images? Look at it's like information. There's mountains of it. And I'm going to put all of this code on GitHub about an hour after this video is done. Except I'm going to have comments on absolutely everything. So you can use it as like a cheat sheet for everything you do afterwards. And so I'm looking for the part where I convert everything into 256 by 256 pixels. It is right here. Oh, no, not that. Yeah, right here. This is where you use flow from directory to convert to a target size of 256 by 256. And here we are normalizing with image data generator. So that's what's going on with all of that stuff. And then we used augmentation. We talked about a lot of things in this video. Like if you just understand this video, you're learning a considerable amount. And we're still on Epoch 1. EfficientNet is ridiculously complicated. It's way more complicated than even ResNet is. I have 41. Yeah, something like that. All right. Let me see what happens if I do. I don't want to do something weird here. I'm not going to mess with that. Okay. And I normally play music, but I can't play music because even music that I have purchased, YouTube says that I don't own it. So, sorry. I'm not able to use music that way. Weird. And the only thing left for us to do is to test to see if ResNet works with these different custom images. Anybody have any questions while I sit here and wait? Ask me absolutely anything about anything. Since nobody's asking me anything, when I was something that I figured out that was really cool when I was trying to figure out how to learn how to play guitar is I have a local music shop and I didn't know what type of guitar to use, and you can get ridiculously cheap guitars at local. Hello, Alex. You can get ridiculously cheap guitars at like local music shops if you have one. I mean, dramatically. Because what happens is people get a guitar and they're like, oh yeah, I want to learn how to play guitar. And then they get like a dumb book that doesn't really work and it's not fun to work with, and then they just give up on it. But then they have this guitar that they've owned for 6 months and they've played for like 2 hours. And then they go and take it back to the music shop and sell it. And you can often get a guitar for a third of its retail price, and it's barely even been used. And so I have a local shop, and I went there, and they were really cool. I told them from the beginning, I was like, if I buy a guitar off you, will they let me play? They just let me in where the guitars were, and they just said, you know, you can sample all the used guitars. And there were like 35 guitars in there. And this is going to where I found this really awesome guitar. And I'm not trying to sell it to you because don't even buy it online. Go, if you have a local music shop, just go and get it. Or at least take a look at it. Because it's a guitar I don't think anybody ever pays attention to, that I never paid attention to, that I ended up being like super awesome. So just throwing that out there because I don't have anything else to talk about. I don't know anything about how Google captions. I'm gonna eventually do natural language processing and all of that. I'm basically gonna recreate or try to recreate what Google has for automatically captioning voice. That's coming up, I don't know, next month, something like that. Anyway, so they let me play all these different guitars. And to be honest, the guitar that I ended up first choosing, I picked it because I liked the way it looked. It was cheap. It was like, I got it for like $80. And it was a Squier, but it looked like a Fender because Fender makes Squiers. And so I got that and I brought it home and I played it for a couple days, probably about 4 or 5 days. And I realized I just don't really like this guitar. So the music shop said, well, as long as you bring it back in the same condition we sold it to you, we'll give you your money back. And I was like, all right, cool. Because I told them I will definitely buy a guitar from you. And when I went back, I was like, what is that weird looking guitar right there? And I said, is that a guitar? And they were like, yeah, it's a guitar. It's called a traveler guitar. And I had never seen one before. I had never heard of one before. And it is this thing right here. Here, I'll show you. This is what it is. It's like just the stock, and there's nothing else. And this was used. This is used. You know what's wrong with it? There's like a couple nicks right here. I don't even know if you can see that or not. There's a couple nicks right here where the person that used it before like jammed it in there incorrectly, and then there's some other stuff. But I got this. This thing weighs like less than 3 pounds. And it's absolutely wonderful. I can throw it around. It has like a little rest right here. If I want to take it somewhere, like if I'm going on vacation or I'm traveling, I can take it. And it's my favorite guitar. And it was super cheap. And I found it by accident just because the music shop had it and somebody else bought one and didn't use it. So there's that. I'm blocking people, hide user on this channel, who are going and posting weird things about casinos for some dumb reason. Okay. Yeah, you can use overfitting on anything, but normally if you download a good model, you're not going to have overfitting issues. That's just not something you're gonna have a problem with, because it's the model's trained on different types of data than what you're using, so that doesn't really apply in this circumstance. Overfitting is more whenever you're training your own model that you end up having overfitting issues. But I showed you how to get rid of that. You do augmentation, and that normally handles getting rid of those problems. Boy, EfficientNet is taking a lifetime. This is an extremely complex model, but you're going to see it has really awesome results in the end. Well, thank you very much. I'm very happy that you enjoyed my videos. And a lot of people think like I get, people send him comments and say things all the time, and he doesn't care. He hears it all. And believe me, I appreciate every positive comment, and I read every single positive comment, and I also appreciate negative comments as long as they are, useful. Am I planning? Yes, I will. There is tons. I'm just starting with machine learning videos, and I am going to be doing many, many more. So there is plenty of more machine learning videos that I'll make, and it's just going to take time. That's whenever you're making very complex videos, it takes time to slowly get into and cover absolutely everything. But it also takes, diligence from students that are willing to sit and actually watch the videos, because it's a lot. But if anybody out there that wants a machine learning course that covers just about everything in a practical step-by-step manner from the beginnings to the more complex, hopefully this provides that. And like I said, it's 100% for free. So... and the code's for free. I'm gonna upload all this code to GitHub as soon as I am done with this video. If you want to know where, let's just go here. Oops. Let's say this. I'll post the link. So GitHub, and what is it called? Show more. Where did I save this at? I have all kinds of stuff on my GitHub page. So much code that I can't even find what I'm looking for. There it is. TensorFlow. All right. This is where I post all of my video content. So I'm going to post it right here. Make them fun. It would be... that is where I am posting absolutely all of my content. All of the videos here. Please make them 5-6 years later. It would be great for the upcomers. All right. I will do my best. So that's where all my code is. And like I said, it's heavily commented. You can use it as cheat sheets and things like that to be able to learn all this stuff. And this model is taking a lifetime. All right. Well, I'm going to get a couple of things here in order. And unless you guys have other questions. Because this model's taking forever. Sorry, this is what it does. Figuring out how to create a model for... Can I ask some questions in your Discord? I'll prepare some info and try to share if it's okay. Sure, you can ask anything on the Discord you would like. Let's go. Can at least see if I can get a link to my Discord. I'll help if I can. Where is it? I'm trying to get this to work. Boom. Getting a link to my Discord and posting it here. And edit it. Expire after never. No limit. And copy. Alright. And here is my Discord. Boom. And boom. Is the chat showing up? There it is. Yeah. So there's TensorFlow. And if you're wondering why your chat messages aren't showing up, the only chat messages that show up are the ones on Twitch. And I can't do anything about that. That's just the way my software is set up. To do software developing videos and software. Like what in specific? It says, are you planning to do software developing videos in the future? On what? I mean, this is software development, and it's just specific to machine learning. So I don't know what you're specifically looking for. I basically just make videos based off of requests that people make. The only negative with that is because I normally cover topics in massive detail. Like I spent, what, 3 months or 4 months applying data science to the stock market and investing. Like most people don't do that. So normally if whatever the next hot topic is, it normally takes me 4 months to actually start making those videos. So it's just the way it is. Are you planning on... Oh, QT. I already did QT videos. I didn't do a lot with them. If you're talking about desktop applications, I have videos on that already. For Python as well as C++. I don't believe I did it with anything else. And desktop applications. At some point I'm going to do a C# video tutorial in which I cover desktop applications and mobile applications on Apple and Android devices. That'll probably be the thing I do after machine learning. And but I don't have any idea when machine learning is going to be finished. In the last video, I showed how to save the model and then load it later on. And at some point, I'll show how to export a model and use it in Google Colab, or use it with TensorFlow Lite as well. It's still calculating, if you're wondering. Yeah, I'm afraid to touch anything to show you. If you look at the code for the last video, you'll be able to see at the end, I show how to export the model and then reload the model to use it. It's in the last video that I made on convolutional neural networks. I know I talked about convolutional neural networks in this video, but I did it with MultiClass. Convolutional neural network. CNNs. We're almost sort of done. And I see people are leaving now. You're not going to find out how good EfficientNet is, though, if you leave. Actually, let's look at EfficientNet, 0.839. So we got 84%. And remember, 5% is like 50% because we're doing 20 classes. As you increase the number of classes or types of food that you're searching for, that brings down the percentage for guessing, which would normally be 50% if you're only going to have one or another object. Well, now we have 20, so you take 100 divided by 20 and get 5. So this is 83, which is actually, it's way higher than 83%. And ResNet was 78. So EfficientNet is already outperforming ResNet. And this is, the 83 is with the validated or test images that it never saw before. And it's already, well, this is up to 88, but that's with the training set. So it's getting better and better and better and better. Yeah. Well, the EfficientNet model is ridiculously complex. So that's the reason why it takes longer to calculate. And I'm drinking green tea, if you're wondering. Yeah, that's what it is. Here. And you can also see, I was trying to show you that I have a green screen, but it didn't work. All right. Well, I think I'm going to go get myself some more tea. So I'm going to be back here in a minute, and then the rest of the video will just be me testing EfficientNet to see if it works. All right. So be back in a second. All right, I'm back. It's still not done yet. Here it is. Still calculating. It's almost done. It's very, 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 very close. And then we will know how good EfficientNet is at working here. We have our accuracy on the training data is up to 90. On validation, it's at 84. It's ridiculously accurate. It's remember, 84 is way better than that. Is there anybody that has watched this entire stream for 2.5 hours? It's definitely a very long stream packed with a ton of information, and I think this gives you a very good idea of what it feels like to be a data scientist. This is what you do. You make these models, and then you sit here and you wait for them, and then you test them to see if they work or not. How am I able? I'm sort of just getting over my cold, Stan. It's sort of a cold. My medication is working, so that's a good thing. It wasn't working this morning. I have long COVID is what my disease is. And there's no cure for it, and they just give you random things, and there you are. You came late. Oh, that's all right. This is a long stream that covered immense amounts of information, so a lot of stuff to go through. There's not going to be a live stream next week because I have to travel and I'm not going to be able to do it. Best way to test machine learning to see if the computer knows the difference between a muffin and a dog. I can guarantee you this model will be able to tell the difference between a muffin and a dog. It's pretty good. Oh, looky, our casino thing's back again. They are definitely. I hope this isn't a real human being that's wasting their time doing this. It's some sort of bot, at least. All right, we're almost done. EfficientNet is almost finished, and it is finished. Okay, let's see how good it does at going and recognizing our different things. So can EfficientNet recognize pizza? Let's come in, and let's paste this here, like that. And then all we do is change this to EFF model. EFF model. Nothing else needs to be done, and run it. Chicken wings. Oh no, I thought it said chicken wings. I just read that part. And it's pizza. Okay, can it recognize chicken wings? That is the next thing we want to test. So copy, and let's throw this down inside of here. Paste, and just change this to EFF model. EFF. Boom. Chicken wings. Immediately it knew that was chicken wings. And then let's test to see if it can recognize apple pie. Remember, my original model failed on apple pie, but it got absolutely the other things all correct. So let's try this and run it. Apple pie. So it's accurate, and it has an accuracy that is at 84, which is ridiculously accurate. So there you go. Thank you to everybody that joined me. I'm stuck in a pickle. I usually use SDD for an image with bounding box as relevant. I normally use SDD instead of YOLO. You might want to try that. SDD is slower but more accurate, but not dramatically slower. So that might be something you might want to do. All right, so I covered so many different things today. Thank you to everybody that joined me. No machine learning videos, no videos at all next week. I am traveling, and I just won't be able to do it. So thank you to everybody that stopped by, and I will catch you next time.